Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the DFA designing process, we have seen examples in which the DFAs which accept strings of length at least 3, at most 3 and exactly 3. We are going to see similar question using now NFA designing. Let's see the first one, the NFA for accepting strings of at least 3. Here, Q0 is the initial state. We need to keep track of length, so we will track of both 0 and 1, length 1, length 2 and length 3. Now on state Q3 we have already seen 3 symbols. Now whether it is 0 or a 1, it doesn't matter, we have already seen a length of at least 3. So Q3 is going to be the final state, plus all the transition from Q3 will be to itself, marking Q3 as final state and Q0 as the initial state. You see here that this NFA will accept strings of length 3 or more. Any string, like for example 1 1 1 1 will be accepted. Any string having length less than 3, that is let's say 1 1 or 1 0, will be rejected. Let's see the mathematical definition of this NFA. Let's name this M9, having the component Q, sigma, delta, Q0 and F. Over here, Q is the set of states, Q0, Q1, Q2 and Q3. Sigma is the input alphabet set. Over here it is 0 and 1. Delta, let's draw as a table. On Q0, Q1, Q2 and Q3, we have transition to various states for the input symbol 0 and 1. Let's mark the initial state Q0 and the final state Q3. On 0 or a 1, Q0 have a transition to Q1. Similarly, Q1 have a transition to Q2. Q2 has a transition to Q3. Q3 is the final state. For further symbols, Q3 will be having transition to itself. So we have seen Q, we have seen sigma, we have seen delta. Q0 is, as already mentioned, is the initial state and F is the final state. Here it is going to be Q3. Essentially in this question you will see that the machine that we have designed is exactly looking like a DFA. Here we can say that every DFA is by default an NFA. In a few videos later we will be saying the topic of equivalence of NFA and DFA, but this is just a resemblance. The next question is designing an NFA which accepts strings of at most 3 as the length. Q0 is the initial state. We are keeping track of length with various states like Q1, which tracks of length 1, Q2, which keeps track of length 2. As soon as the length is 3, let's say Q3 is the state. Now, we don't need trap states in an NFA, rather dead configuration itself will reject any string which is having length more than 3 over here. So, length 0 is allowed, length 1 is allowed, length 2 is allowed, length 3 is allowed. Any length more than this will be going to a dead configuration. Let's name this machine M10, having configuration Q, sigma, delta, Q0 and F. Q is a set of states. Over here it is Q0, Q1, Q2 and Q3. Sigma is the alphabet set, 0 and 1. Delta as a table. It will contain Q0, Q1, Q2, Q3 and Q0 is the initial state. All of them are final states. Have a transition on 0 or 1. Q0 have a transition to Q1. Q1 has a transition to Q2. Q2 has a transition to Q3. And Q3 had no transition, so it is going to be a dead configuration. We have seen Q, we have seen Q, sigma, delta, Q0 is the initial state, the final state F, which is containing all these states like Q0, Q1, Q2, and Q3. Let's see the last example in this category, that is constructing an NFA containing the set of all strings which has length exactly 3. Here we are taking Q0 as the initial state. Now we need to get only those strings which has exactly 3 as the length. Q1 keep track of length 1, Q2 keeps track of length 2, and Q3 keep track of length 3. On length 3, this is going to be the final state. Length 0 is non-final, length 1 is non-final, length 2 is non-final, length 3 is final, length 4 or onwards will go to a dead configuration, which is again going to be non-accepting. Let's name this machine with M11 having component Q, sigma, delta, Q0 and F. Q is a set of states. Over here it is Q0, Q1, Q2 and Q3. Sigma is the input alphabet. It is having components 0 and 1. Let's draw delta in the form of table. Q0, Q1, Q2, Q3. Out of them, Q3 is the final state, Q0 is the initial state. On alphabet 0 and 1, we have following transition. Q0 has a transition to Q1, Q2, Q2 has transition to Q3, and Q3 have dead configurations. We have seen the set of states Q, set of input alphabet sigma, delta in the form of a table, Q0 is the initial state. Let's mark the final state F with Q3. From the next video, we will see the equivalence of NFA and DFA, why they are having resemblance with each other. Thank you for watching this video. Stay tuned to the channel Ekeeda and do subscribe to the channel Ekeeda. Thank you.